Hello again, greetings, and welcome back. Thank you for tuning in again. Thank you for tuning in. So now we're going to get into lesson 6. Okay? We're still doing chemical change. Okay, so we're going to do question 7 today. This is November 2023. You see, it's from KZN. Okay, so this was done in November. So this question here is about chemical change. So let's read the question together. A sample of impure solid calcium carbonate, okay, of mass 12.5 grams reacted with dilute hydrochloric acid HCl according to the balanced equation. So now a sample of impure. So now we can see already that this is the mass, you see, mass of the sample. Mass of the sample, they say is impure. You see, a sample of, so we see already that this is the mass of the sample. See, now of mass reacted with dilute hydrochloric acid according to the following balanced equation. So they gave us a balanced equation here. Calcium carbonate, and then HCl, hydrochloric acid, calcium chloride, carbon dioxide, and water, H2O. You see? So these are the products here, and the reactants. So 3 products, 2 reactants. And then they gave us something here that we can work with. They say the graph below shows how the mass of the HCl AQ changes with time. Okay, changes with time. Okay, so mass, it started at 20 and then it went to 12.7 and it stopped. After 12.7, it was constant. They say define the term limiting reagent. What is a limiting reagent? 7.1. So a limiting reagent is what? A reactant. A reactant that is completely, or you can say that is okay, let's use this time. A reaction that is consumed completely. A reactant that is consumed completely during a chemical reaction. During a chemical reaction. During a chemical reaction. This is the definition of a limiting reagent. And then in this case, what is happening? What does the graph tell us here? They say write down the name or formula of the limiting reagent in the above reaction. Okay, so how can we know from the graph? What can we see here is that the mass of HCl is shown on the what? On the vertical axis. The mass of HCl starts at 20, and then it goes down, and then at 12.7 it stops. It becomes constant. The line here is horizontal. So this shows you that what? HCl is no longer being used. So it is constant, it's not going down anymore, it's not being consumed. See, the line becomes horizontal here. So what does that mean? It means that because if HCl was completely consumed, the line would go down until 0, isn't it? It would go down like this. This line would start here, and then it would go down. It would become horizontal at 0 here. You see? So the fact that HCl stops somewhere here, it shows you that at some point it is not being used up anymore. So it's not being used up completely. It's the mass. We can find the mass. We can say 20 minus 12.7 to find out how much mass was used. So it means that because we only have 2 reactants, so if it's not HCl, it means it has to be calcium carbonate. See? So write down the name or formula. I'll give you both, okay? I'll give you both. So it's gonna be calcium carbonate. This is the name, calcium carbonate, or you can use the formula, which is CaCO3. And then 7.3. So I hope you understood today. Okay, this is how we know that calcium carbonate is the limiting reagent, because we know for sure that HCl is not there. So there's only 2 of them. Is the HCl, hydrochloric acid, or it can be calcium carbonate. So from the graph here, we can see that it's not HCl, because HCl is not completely used up. It does not stop at 0. So it's not completely used up there. It's the excess reagent, not the limiting reagent. Now we go to 7.3. 7.3, they say calculate the percentage purity. Percentage purity of the calcium carbonate. Okay, so we have to find the what? Isn't it? We have to find the mass. We know the mass of the sample, but when we don't know the mass of the compound that reacted. So we know the mass of HCl that reacted, isn't it? We can say 20 minus that. So we can find the mass of the HCl. So this is what we're gonna do. So the mass for what? For HCl, the mass that what? That reacted. You see? The mass that reacted. We're then going to say 20 minus 12.7. Minus 12.7. Then we get what? 7.3 grams. And then we can find the number of moles, isn't it? That reacted. Then we can find the number of moles. If we have the mass that reacted, then we can find the number of moles for what? For HCl that reacted. Then we're then going to say m over m, and then here's going to be 1 plus 35.5, and then 7.3. So these numbers, they come from the periodic table, isn't it? It's for H and Cl. They come from the periodic table here, which is given in the exam. And then you use a calculator here. Okay. It gives me 0.2, okay, 0.2, okay, let me see, 7.3 divided by 36, 36.5. It gives me 0.2, yes, 0.2 moles, okay. Now, this is the number of moles for what? For HCl. We have to find the number of moles for what? Calcium carbonate. Now, you may ask at this point, okay, now, but then this doesn't make sense. Why? They're asking us for the percentage purity. So what are we doing here? Why are we finding the number of moles? Why are we finding the mass and the number of moles? So you have to understand something, okay? We have to understand that what? This question is a long question, you see. It is 6 marks. So it has a few steps. It's not a simple question. It's not a simple, okay, you just use one formula, then you are done. You see? So there's a process and you have to understand the process. Isn't it? When they say that find the percentage purity, find the percentage purity of what? Of calcium carbonate. This formula for percentage purity is what? Is you have to say mass of the compound and then divided by mass of the sample. Okay. So what we have to find here is the mass of the compound. You see, we don't have that. So the process that we're doing here is helping us to find the mass of the compound. Because what we're doing, we have the mass of the sample, isn't it? We have the mass of the sample, which is 12.5. Because they told us that a sample of impure solid calcium carbonate of mass 12.5. So we have the mass of the sample, but then we don't have the mass of the actual compound. What does that mean? It means that the sample is impure. You see, the sample is impure. So what that means is that it has calcium carbonate and then it has other compounds, the impurities. So what we're doing is that we're trying to find the mass of only calcium carbonate inside the impure sample. You see, I hope that makes sense. But I'll explain as we're going down. So now, what we did here, we found the number of moles of HCl. Right? Those number of moles of HCl will help us find the number of moles of what? Calcium carbonate, because then we can go to the balanced equation. You see, we can then use the ratio. You see, the ratio for calcium carbonate and HCl is what? Is 1:2. So now, calcium carbonate and to HCl, the ratio is what? Is 1:2. So we have HCl, and we have the number of moles of HCl, which is 0.2. You see? So 1 mole will react with 2 moles. So it means 0.2 moles will react with 0.1. See? 0.1. For what? Calcium carbonate. It just makes sense, isn't it? If you have 1 here, you have 2. So it means if you have 0.2, then this side you're going to have 0.1. See? So this is the number of moles for what? For calcium carbonate. Now, watch, then what's going to happen? That number of moles then will help us to find the mass, isn't it? Then, because then we're going to come here and say N equals to M over N. And then we're going to substitute that here. Then we're going to say 0.1 equals to, this comes from the periodic table. It's going to be 40 plus 12 plus 3 times 16. And then the M. So then it's going to be, when you add all these things, you get what? You get 0.1 equals to M over. So you add, use a calculator. It gives me 100. So then it means therefore M will be equal to 0.1 multiplied by 100. So then it's going to be 10 grams. So now this is the mass of the compound that we're looking for, because the number of moles that we're finding here is for what? Is for calcium carbonate. The percentage purity that they're looking for is for calcium carbonate. So that's why we had to find the mass of the compound that they are looking for here. See? Then after that, that's when we can find the percentage purity. Now, the percentage purity then is going to be mass of compound, divided by mass of sample. Mass of sample. Mass of the sample multiplied by 100. Then we can substitute, you see. Then the percentage purity, we can find the percentage purity. It's going to be 12, 10 divided by 12.5. The mass of the sample, we have it, multiplied by 100. Then you use a calculator. Gives me what? 80%. So you see that all this process, we're doing it so that we can find the mass of the compound. Mass of the sample, we have it already. So the mass of the compound, we have to find the number of moles of the calcium carbonate, such that we can use that number of moles here to find the mass. But we couldn't find the number of moles before we had the number of moles of of the HCl. Because the HCl that is reacting here, isn't it? It's reacting with the calcium carbonate, isn't it? According to the balanced equation here, the HCl is reacting with the calcium carbonate. So the HCl that is decreasing here is decreasing because it is reacting with calcium carbonate. So I hope that makes sense. So let's go to 7.3.2. 7.3.2 is, so 7.3.2. Let us go to 7.3.2. Maximum volume of CO2 produced at standard temperature and pressure. So now, to get the volume here, we have to get the number of moles, isn't it? Because that formula here, the formula here is like, isn't it? E N equals to V over Vm. And then if they say at standard temperature and pressure, do you remember what this means? This means that the molar gas volume will be taken as 22.4. That's what standard temperature and pressure. The molar gas volume is 22.4 at standard temperature and pressure. So we have this already, but then we have to find the number of moles of what? Of calcium, of carbon dioxide, I mean to say. So now we come here. We're going to look at the what? The ratio. The number of moles. So we can see that the ratio for calcium carbonate and for carbon dioxide is 1:1. There is 1 here and there is 1 there. So now the number of moles of what? The number of moles for carbon dioxide will be equal to the number of moles for calcium carbonate. So then it will be equal to 0.1 moles. Why? The reason is these two things have a 1:1 ratio. See, the reason is what? Is 1:1. They have a 1:1 ratio. So the number of moles that we found here will be equal to the number of moles that we found. So which is 0.1. So then when we have that, then we can then come here and say n equals to V over Vm. And then we can come here and say then V equals to n multiplied by Vm. And then we can use the number of moles that we found there, 0.1 multiplied by 22.4. You see? So you should know where you are going when you're doing calculations. You should know that, okay, in order to find this value, we must find something else before and then use that something else that we found before to calculate what is being asked for. Okay. A lot of these kind of questions will be asked. So it's not as simple as what? As ABC, because you have to find something else and go and use it somewhere else, and go and find something, go and use it somewhere else. And you should know when you see these questions that this is what is being required. You will find long questions like this, whereby the question is 6 marks or 7 marks or 8 marks, you see? And so you should know that, okay, the first thing that I need to do is this. And then when I'm done doing this, I have to do that. Done doing this, I have to do that. When I'm done doing this, I have to do that until I get to the final answer. Because if a question is 6 marks like this, it means it's a long question. If it's a 6 marks or 7 marks, it means that there's a lot of steps that you're going to have to do before you get to the final answer. See? So it is incumbent that you know those steps. But don't worry, okay? As we're doing a lot of questions, you will see. So guys, don't miss lessons, please. Don't miss. Tune in every day, okay? So that you see and you familiarize yourselves with the work. So, okay, let us go to 7.3.3. 7.3.3, they say what? In another reaction, X grams of the same impure calcium carbonate is now reacted with excess HCl. Okay, they say calculate the mass of the impure calcium carbonate that must be used to produce 12.6 grams of H2O. Okay, so we have what? We have H2O here. So we have the mass for H2O. What this can do is it can help us to find the number of moles of H2O, isn't it? the first thing we do, we find the number of moles for H2O. I want to say N equals to 7.3.3. So we're then going to say N equals to then the mass here is 12.6. 12.6 divided by 18 equals to, you use your calculator here, gives me 0.7 moles. So now we have to compare calcium carbonate and H2O. We go to the balanced equation. You see? So calcium carbonate and H2O, the ratio is 1:1. Okay, there is a 1 here and a 1 here. So it means they will have the same number of moles. You see? So then if we found 0.7 here, we're going to say then the number of moles what was calcium carbonate needed for that will be equal to the number of moles of what? Of H2O, see, which is 0.7. The reason for that is there is a 1-to-1 correlation according to the balance equation. Then we can find the mass, isn't it, for that. Then we come here, we say N equals to M over M. Then this time we use calcium carbonate. And then for calcium carbonate, we're going to use this 40 plus 12 plus that. And then it gives me 70 grams. You see? But then the question is asking something else. The question is asking the mass of the impure sample, isn't it? They're saying, calculate the mass of the impure calcium carbonate that must be used to produce 12.6 grams of H2O. It means that the pure mass in this case is 70, isn't it? So then we come here. We know that the percentage purity will be equal to mass of compound. Yes, this is mass of compound. And then mass of sample. Mass of sample. Then multiply by 100. So we know that the percentage purity, we found it before, is 80. You see? So it's going to be 80. And then mass of sample. This is what we're looking for. Mass of sample. then the mass of the compound, we found it here to be 70, and then multiply by 100. So, okay, we have to change the subject. So then we have to change the subject. So then it means, therefore, mass of sample, we just changed. So we swap, we pick the 80, we put the 80 here. Mass of sample. So the sample that should be used here is going to be 70 by 80 multiplied by 100. And then it's going to be equals to how much? Use a calculator here. It gives me 87.5 grams. 87.5 grams. This is it. So it means that this is the mass of the sample that should be used in order to get that mass of 70, which is the mass of 70 that is going to give us those number of moles. This number of moles of the what? H2O, 0.7. Okay. Yes, I think let's leave it here, okay? Let's leave it here for lesson 6. I hope that was helpful. And thank you for tuning in, okay? Thank you for tuning in again. And please leave your comments in the comment section. Leave your comments in the comment section and ask your questions, guys, okay? Feel free to ask your questions wherever you don't understand. Goodbye for now. Take care of yourselves and stay focused. Bye-bye for now, and I hope to see you. I hope you tune in for lesson 7. Thank you.